With piecewise functions, you are looking at each problem and trying to figure out which function do I need to plug it into. So the first one is g of 6. For g of 6, you find the g function, which is the one on the right. 6 is bigger than 0, so we're going to plug it into the bottom. So half of 6 plus 5. What is half of 6? And 3 plus 5 is 8. So I tried to make this so you could do most of it mental math if you can just pick the right formula. F of 2, f is this function on the left. 2 is smaller than 3, so we're going to plug it into the top. 2 plus 5 is 7. F of 3, which one of these should I use, top or bottom? Top, because 3 equals 3, so 3 plus 5 is 8. G of negative 3, we're using the function on the right. Negative 3 is smaller than 0, so use the top. Negative 3 minus 4 is negative 7. G of 0, 0 equals 0, you use the bottom. Half of 0 is 0, 0 plus 5 is 5. And then finally f of 4, so we're back on the left. 4 is bigger than 3, so we're going to use the bottom. 5 times 4 is 20, 20 minus 2 is 18. How many of you got that big of a number and thought, oh crap, I did something wrong. All the numbers are single digits and now this one's double digits. I must have done something wrong. Try not to second guess yourself like that. Sometimes it's a bigger number. It just happens. Okay, this one I know is annoying on your screen. So you've got these functions on the left that we're going to drag over and match with the corresponding graph on the right. The problem is this is a very long screen with these 4 big graphs, so we may have to drag this a long way down to the bottom of the screen. So what I would do is look at the function and think about what should that graph look like. Find that graph before you start dragging. So 4 in front, that's a stretch. Also in these graphs, the black one is the original, the blue is the new one. So you're looking for the blue graph that matches our equation. So we want the one that's super skinny. That's all the way down here at the bottom this time. So I'm going to grab this and start dragging down, down, down till I get to the bottom, and then match it up with the graph. My next one is x plus 4 inside the bars. Plus 4 inside the bars means left 4. Oh, hey, that one's right here. That's nice. The next one is minus 4 outside of the bars. That would be down 4. So I look through my graphs. Down 4 is up here at the top. So I'm going to grab this, drag it toward the top, and match it up. So this one should be negative. Yep, that looks right. Match that one. And then just once you've dragged everything where you want it to go, if you made a mistake, you can click this little red circle thing, and that will unlink that one, and then you can redo it. So if you make a mistake, you can click that little red button to unlink it and then fix it. But I would make sure that you take a minute to look at what you have linked and say, yep, that looks right. Yep, that looks right. That looks good. That looks good. So once you have them linked, recheck all of them before you go on to the next question. This is very similar to the assignment that we did on, was it Monday? This graph, does it open up or down? Up, because there's no negative in front. It is a stretch because that number in front is bigger than 1. This is the only one that we didn't have on that assignment before. But what do you think the answer is? Stretch by a factor of 5. There will not be negatives in any of these drop downs on the test. Yeah, it's weird. Horizontal translation, plus 2 means left. Left takes care of the negative, so this is going to be 2 units. You don't want negatives in those three boxes. And on the test, I took the negatives out because that's just confusing. This is a vertical translation down. This graph moves down, and it moves down 3 units. Honestly, like -2 units or -3 units doesn't make sense because distance isn't negative. So when you're talking about moving on a graph, you're talking about positive numbers. But on the test, these 3 boxes will not have negative options. It will only be positive options to make it less confusing. Okay, we made this question very similar to an ACT question. You could take the time to read that entire paragraph at the top, but you know what that paragraph at the top does? It verbally describes this piecewise function that's shown right here. I wrote the piecewise function for you. You don't need to write it, so you really don't need the paragraph. The only thing you need in this paragraph is the very last sentence. Do you all know that in math, the last sentence is the most important? Whereas in English, the first sentence is the most important. So you can highlight that last sentence and click the little highlight button. Which graph models the piecewise function? And if you look through these graph options, I think you're going to notice that all of the graphs are exactly the same. The only difference is the dots. So what should the dots look like? On the left, we have less than. On the right, we have less than or equal to. Our dots should be open to closed. So if you want to use like the answer eliminator tool, you can. This one's not open to closed. That one is closed to closed. That's not it. That one's open to open. That one's not it. D is open to closed. That's the one we want. I got to get rid of this answer eliminator tool so I can actually click my answer. Open to closed. This question is checking to make sure that you know what the plus and minus in each spot of the absolute value function does. So down here, this +2 inside, that means left 2. Are these really in order? They almost are. -2 inside means right 2. -2 outside means down 2. And +2 outside means up 2. And those will be in random order at the bottom. Sometimes it's in order that's nice, and sometimes it's totally random. And that's it. Let's see how we did. Woohoo! 100%.
How many questions are going to be on the test?
Same. There's going to be the same number of questions on the test that there are on the review.